Yes, friends, welcome back to Pure Math School. Today we're still continuing with our introductory work. That's the 8th part, the three-dimensional trigonometry. And we are still continuing with more examples. As in the previous video, we looked at one example. And now today, this is our question for today. A particular hillside may be considered to be a sloped plane or a plane inclined at 15 degrees to the horizontal. And a straight path up the hillside makes an angle 30 degrees with the line of greatest slope. The question is, find to the nearest degree the angle the path makes with the horizontal. So let's try to handle that question and see how we can go about it. Let us assume that this is our horizontal plane. Something like that. Yeah, say that's our horizontal plane, and they're saying that let's try to flash back and see the question again. It's saying that the hillside may be considered to be a plane at 15 degrees to the horizontal. So that means we can draw a plane. Let us say a plane goes like that. Okay, this horizontal makes 15 degrees with the horizontal. Then we drop that to be the height of the plane at that point. Okay, that's the height of the plane. Makes 15 degrees with the horizontal. That's 90 with the horizontal. The question continues to say that a straight path up the hillside makes an angle of 30 degrees. Straight path up here makes an angle of 30 degrees with the line of greatest slope. Remember, in I think the previous video, not the last one, but the previous one, but one, we said that a line of greatest slope simply means that the slope is inclined at some angle to the horizontal. So that means our line of greatest slope is always at 90 degrees, but when the plane is inclined at some angle, it means the line of greatest slope is inclined at that angle to the horizontal. So now they're saying that the path up the hillside makes an angle of 30 degrees with the line of greatest slope, which simply means it has made an angle of 30 degrees with the incline, with the slope, with the incline, with the inclined plane, not with the horizontal. So since a line of greatest slope, that means this is a line of greatest slope which has made 15 degrees with the horizontal. Now they're saying another line up makes up the slope makes an angle of 30 degrees with a line of greatest slope. There, 30 degrees. Okay, still we try to drop a perpendicular from that point to the we can say that let's try to make it there also with the horizontal is making 90 degrees if you drop a perpendicular from up there. Okay, now what do they want us to find? So we can connect this and see. You can see that if you connect that, we can have that just like this. Let us see what the question says. Find to the nearest degree the angle between the path makes with the horizontal. Okay, so actually now they want us to find the angle this path will make with the horizontal. But our horizontal, let's draw a line that joins there to give our horizontal. That's 90 degrees up to there. Still also 90 degrees if you draw up to there. Okay, let's give that, let's say, angle theta. Okay, and this h, let's say we have a point here A. Let's say that our plane maybe goes in that sense, something like that. That's our inclined plane. That's also that. So we have that as our inclined plane. So now we have there, at that point we can get that point here, and we can also relate. Now we have that, we can say that we have here, let me say B, C and D. That's our plane which is inclined at 15 degrees to the horizontal. Now we see that this one makes an angle of 30 degrees with that. That means we can also let that come to this at 90 degrees at that point. Let me say there. Okay, this 30 degrees for this one. That makes angle 30 degrees with the inclined plane. We drop a perpendicular there. Say this is at the height, which is from this point up to down, from that point up to down, same height. So we can name this point here to be, let me say V. We name this to be, let me say G. Which other one we can give here? D. No, like we already used D. E. Then we use here, let me say F, where that touches us down there. Then we can put here H. Okay. Yeah. Letters don't matter so much. So now they want us to find this angle theta. Or with that angle theta, we can use it by getting sine theta or tan theta or cos of theta. Okay. Whereby our sine theta will be given by the opposite of that, which is VF out of the hypotenuse, which is AV. Okay. Our tan will be given by VF, the opposite, and the adjacent, which is AF, which is VF out of AF. Then our cos will be the adjacent out of hypotenuse, which is AF out of AV. AF out of AV. So it's upon us to use any of this so that we can reach to get our theta. Let's suppose maybe we say we choose this, but we have to now see which one is easier. I think if we first have to get our vertical height, would be the best way to do that. If you get our vertical height, because the height is very crucial here. Let's say to get our vertical height, let's say we are using, let's say sine theta. It's going to be given by VF out of AV, since VF is what our vertical height, which is the same as from that point down here. Okay, so we say that, well, how can we find VF? I think we first consider this from this point up to here also. That's our height from there up to here. Height from here up to the point, from there up to that, then height from here up to here, we can consider that. Let's consider this triangle AGH. Consider triangle AGH. Okay, that means we can get here what can have our GH, which is the vertical height, which can also be the same as VE, which can also be the same as VF, which is still the vertical height. We are getting a way of getting the vertical height, since our vertical height here we have VF, which is the same as getting GH or VE. So now we can say that we can use sine, since sine has opposite and hypotenuse. Sine 15, okay, 15 degrees is going to be the opposite, which is GH out of the adjacent, which is AG. I mean hypotenuse, which is AG. Okay, that means our GH is actually given, sorry, you can't see that. That means our GH is actually given by AG sine 15 degrees. Okay, that's our GH. When I was GH is the same as VE, also the same as VF. Okay, which is equal to VE, which is equal to VF. Okay, so that means actually we can say that GH is given by VE. GH is actually OVE, OVF is given by AG sine 15. So what's our AG for this case? Our AG is that point, which is the same as the length of the moved up to there, since we have just produced it there. So that means we can get our AG next, since we have a problem there. We don't have AG. So how can we get our AG? I think our AG we can get from this, from that. I think AGH. We can try to get AG from there. Let's go ahead. So we are going to consider triangle AGV to get, in order to get at least AV. I mean AG. Okay, AGV. Okay. So from triangle AGV, I think the angle there is 30. We have 30 from there up to there. That triangle, we have 30. So we can get what considers our AG will actually come from this adjacent. This angle is adjacent to that 90. So that means we have our adjacent AG. That means we consider a trig ratio that has adjacent, which is cos. So if we get cos of 30, we're going to have AG out of AV, adjacent out of hypotenuse. So we can say that cos of 30 degrees is going to be given by AG out of AV, which is our hypotenuse. AV. Okay, Now that means actually our AG implies that our AG is given by AV cos 30 degrees. Okay, now what does it imply here? It means that we have actually got our VF, which is that from VF equals to AG sine 15 degrees. It implies that if we substitute for that, we are going to have now AV cos 30 replacing AG, since AG is that. So we say AV cos 30 degrees, then sine 15 degrees. AG sine 15. So AG is that. You just replace this. All of this is AG, then sine 15 is that. So now we can see that we have our VF, which is sine theta. From sine theta here we need VF and AV, but our AV is our hypotenuse. I think it's repeating here. Our hypotenuse is AV. Let's try to say that we have our sine theta will be actually our VF, which is, remember we got that sine theta was VF out of AV. So we have our VF as AV cos 30 degrees sine 15 degrees. Out of that that AV, we can see that AV is going to cancel out. We don't have any headache now to look for AV. So our sine theta will actually become cos 30 degrees sine 15 degrees. Okay, that implies that theta is actually arc sine or inverse sine of cos 30 degrees sine 15 degrees. Then we need a calculator for that case. Now, how do we get that on a calculator? We first get cos 30, then multiply by sine. Okay, I think I put like this for you to see clearly, but you'll just be observing on the screen. We have put it on. We have cos is here, cos of 30. Okay, is going to give us that. Then we just multiply our answer by sine of 15. Sine is here, sine of 15. We're going to get 0.224 and on and so on. Then arc sine, we're going to press shift, then sine to give us arc sine of the answer. That will be 12.9. But I've said we round up to the nearest degree. Nearest degree, that means we are not going to put in terms of decimal places. We're just going to put the nearest degree, since this is 9, so we can round up to 13 degrees. And so we have our theta equals to 13 degrees to the nearest degree. Yeah, I think we have got the angle that the path makes with the horizontal. Now we can go ahead, we can maybe add another question. Let's go to the second question of the day. It's a rectangular based pyramid. Let me see, PQRST has its vertex T vertically above the midpoint M of the side PQ. And now let's say if PQ is given to be 24 centimeters and QR given to be 5 centimeters and TQ given to be 20 centimeters, calculate to the nearest degree. First part of that question. Then the angle between the plane, the angle between the plane RTS and PQRS, these planes. Okay, so the second part of that question will be the angle between. Let's find the angle between, let me say, skew lines. Question says the angle between the skew lines RT and QP. We have to interpret that question in terms of a drawing. Let's draw on the other side, so we'll do most of the work this side. Saying a rectangular base pyramid. Let's draw rectangular base. Something like that. The thing that vertex T is vertically above the midpoint M of the side PQ. Vertical above the point. Let's take this side. Vertical above this point. Let's say T is there. Midpoint of the point M. Midpoint of PQ. Okay. Midpoint of PQ. Now they are saying that M midpoint of side PQ. So we have, and PQ is 24. That means this side is 24. But rectangle, that means that side is same as this. We can just write that 24 down here to avoid congestion up there. We have 24 centimeters there. And QR is 5 centimeters. PQ, then I think R we can put here. 5 centimeters, that length. Then they're saying that TQ 20 centimeters. TQ, but this point Q, that means T, we're going to join T and Q to get TQ. They're saying that is 20 centimeters, that side. Okay, that length. Then for the case there, they've given us for the provision. Now calculate to the nearest degree the angle between RTS and PQRS. The rectangle is PQRS, that means here so since it's a pyramid, we first have to join this point. We can let this one go up there, then we join that there, then we join this one there. My drawing is not so good, okay, but that's it. Then we can maybe make that parallel to that side also. That means this point is the same as, let's give this point K, which is that. Now they want us to find the angle between the planes RTS and what this meeting here at 90 degrees square, I guess. Even there it's 90 degrees, even there 90 degrees. We can first observe our 90 degrees there, perpendicular to that, perpendicular to that, perpendicular to this. So they wanted to find the angle between RTS and what? RTS and PQRS. Okay, so is this plane here with that plane down there with our base, with a rectangular base. So that means actually if we drop a perpendicular from this to cut the midpoint of this side here, this triangle RTS here, we can join there to be something like that. Since we already have something joining this midpoint and this to this point here, let's just make that line bolder. So is that plane, we have drawn a line on that plane and also a line on this plane perpendicular. This is also meeting here at 90 degrees. Since it's perpendicular, also 90 degrees, meaning also this side 90 degrees from that line. So the angle between these planes, this plane and that plane, will actually be that angle. Let's say theta. Okay. So that angle will actually be it will be actually be the angle between MK and KT. That's the angle we need. MK and KT, that's the angle we need. So that plane, a line perpendicular to it, there a line on it is that, and this plane, a line on it, they meet there at 90 degrees. There this also meeting here 90 degrees, but there is also 90 degrees. So we need that angle. That means for us to get this, we can actually join that vertical height there to this point. This is 90. That meets that point at 9, that M point at 90 degrees to this side PQ. So we actually have that, but you know that we have this distance. So that means actually for us to get this, we can use tan or sine or cos, any trig ratio, but we can see which is easier. We already have here 5 centimeters. That length is the same as this length, 5 centimeters, and there we can have to get this one. We can get also, but let us see. Here is half of this. This midpoint is there, 24. That means here we actually have 12 centimeters. So we have 12, 20. We can get that. Since a right angle, we just say hypotenuse squared minus this squared to give us that. Since right angle, this squared plus this squared will give that squared. So we say from Pythagoras theory, we are going to have mt squared plus 12 squared, that plus this squared equals to 20 squared. So our mt is actually going to be root of 20 squared minus 12 squared. Okay, what is that one? I think that's 16. 20 squared minus 12 squared. 20 squared minus 12 squared, 256, and root of 256 is 16. So we have our mt 16 centimeters. Okay, so we already have that side 16 centimeters. So what do we need? We already have opposite here, since here is also 90 degrees with this. That means actually 90 degrees with this on the line. So that is also the same as this line. This is on the plane, this line is also on the plane. So we have that as our opposite mt, and here is our adjacent, which is 5. So we have tan theta will give us that, which is mt out of km, which means we have mt was given to be 16 out of km. Km is 5. That means our theta is going to be arctangent of 16 out of 5. Okay, what would we have? We have 16 divided by 5 is giving that. Arctangent of answer will give us 72.6 to the nearest degrees. They have said to the nearest degree, so it's 73 degrees. Which is equal to 73 degrees to the nearest degree. I think we have got that. A part. This was A. Now we go to the next part, which is B. The next part is going to be the angle between skew lines RT and QP. B, RT and QP. Let's try to redraw that here so that we can. Okay, we have there RT, (20) here. We have here P, Q, R, S. RT and QP, RT, we join that. Drawing is hard. Okay, then QP is that. So basically we need this angle. Since this one is parallel to that, that means we also need that angle. This angle is the same as that. So the angle between PQ and RT is actually the same as angle between. It's the same as angle between RT and SR. Since PQ is parallel to SR, I think we know that we have something parallel like that. This angle is the same as that angle. So that's the same thing we have here. So we can just now cover that. Then we come back to this since we have something easier. We had like our midpoint here, which was M, okay, which also came here to K in our previous one. Then we had that whole length. Okay, so we had here 5. So if you see this one was perpendicular to this, which is also perpendicular to this line. Okay, I think we can get that from here. This angle we can get from this right angle triangle TKR. or KTR. So we have that and 90, so that we can have, if we have this adjacent and this that opposite and this adjacent, we can actually use tan theta. But now this tan theta, how would we get it? We don't have, we have this which is 12. Yeah, this was 24, the whole of this stretch was 24. Here now we have 12 there, so this is half. So we have this, but we don't have that. But we had this and we had this as 16. In our previous thing we had empty as 16. So since we have 16 there and this was also 90, this was also 90, so that means we have 5 and 6. So 5 squared plus 16 squared should give us KT squared. So we can say KT squared equals to 5 squared plus 16 squared. That means our KT would literally be root of 25 plus 256. Okay, under root. So now what will be our KT? I think it's going to be 25 plus 256. Root of 281 is not exact. We just leave it in form of that, root of 281. So now that means we have, since we have that, we have got this to be root of 281, the whole of that KT. Okay, now we can use that. Tan theta is going to be opposite, which is KT out of KR. Tan theta equals to KT out of KR, which is the same as saying KT is root of 281 out of KR, which is 12. Okay, so theta becomes arctan of root of 281 out of 12. What is our theta? I'm not trying to press. We have root of 281, root of 281 is given by that, divided by 12. Then we get the arctan of the result. 54.4 to the nearest degree is 54 degrees, since 4 is less than 5. So it's 54 degrees to the nearest degree. Okay, we are done with the second part, which is B of that question. So now we look to, I think we can add one more example. Try to see. It is sweaty. So now let's say our third question of the day. Say a particular hillside may be considered to be a plane. Okay, a plane inclined at 22 degrees to the horizontal, and a man walks 60 meters up, let me say due north, up a path which follows a line of greatest slope on the hillside. Okay, let's see. He then, question is continuing, he then walks due west across the hillside, to a point P. From P, the guy moves. Let me say he follows a straight path leading back to his starting point O. Okay, and the length of the path is 85 meters. Oh, this question is freaking long. So they're asking us to calculate the inclination. Calculate the inclination of the total, the inclination of the path OP to the horizontal and the total distance the man has covered. Oh damn it, this question is so long. The longer it is, that means maybe it's easier to interpret. As long as you interpret, it can be easier to tackle. Let's try to check the solution of that. How do we start? Seeing a particular hillside, let's first draw a horizontal to the hillside. Okay, let's say that's a horizontal. Another hill is like that. We drop a perpendicular there to make 90 degrees with the horizontal. So that's now our hill, which we can also extend to be somewhere there. It's like that. That's our hill moving up that way. So now let's see what the question demands. Try to interpret the question. It's inclined at 22 degrees to the horizontal. Particular hillside and go to the horizontal. So we are 22 degrees to the horizontal. A man walks 60 meters up due north up a path. So it's up. Our north is considered to be up the path, which follows a line of greatest slope. Line of greatest slope is the inclination of our plane, which is at 22 degrees. So on the hillside, he then walks due west across the hillside to point B. Let's first. So this guy moves from here to, let me say, a point there. Okay, for 60 meters. Okay, we drop a perpendicular down to the horizontal. So he moves there, starting point O. West is 90 to the, from north. When you go north, just go 90 towards west. That's why I'm putting 90 there. You have your compass direction, shouldn't be reminded, north, west here. So that's that angle between them. So even if you shift it up there, it's going to be 90. West is this side. So that's what why I'm giving 90 there. To a point P. Let's give this Q now. To a point Q. Then from that point P, it moves back. And the length of that path there, it was said to be 85 meters. Okay. So that means they actually want us to do what? Let us first draw our horizontal, this same horizontal. Let's try to also do it here. Okay, that's how this might be perpendicular to this, since this is also on that plane. So now it walks 85 meters back to its original point. This 85, make it clear, 85 meters. Then what do they want us to find? Calculate the inclination of the total path OP to the horizontal and the total distance the man walks. So OP, we need in the inclination of this to the horizontal. Let's just drop a perpendicular to our horizontal. That's 90. Then we give it horizontal, something like that. Okay, let's make it M. We make here to be N. Okay, here H. Okay, this is M. From there, this is horizontal, just making 90 degrees to the horizontal. So they want us to find the angle this inclination makes with the horizontal. Let's give it theta. So we see that our theta can be got from that height. If you use opposite, and let me say hypotenuse, which is already 85. That means we can use sine there to get that. So we need sine. We can use sine theta, which can be that opposite, which is PM, out of hypotenuse, which is OP. But do we have PM? PM is that vertical height from there, vertical height from there. Where can we get that vertical height? OP is already 85. So that means RPM we can get from here. We have here 60. We can get from QN. PM is the same as QM, that vertical height. So our QN, we can say, what can we have? That's opposite hypotenuse. So it's sine. Sine, this still makes an angle of what? 22 degrees with the horizontal. Yeah. No, seriously. Let me check. What's the question saying? So the path man walks 60 meters up due north, follows a line of greatest slope on the hillside. He then walks due. I still 22 degrees, since that the same inclination with this. Let's say sine 22 degrees is going to be given by opposite, which is QN, out of hypotenuse, which is 60. Okay, our QN becomes 60 sine 22 degrees, which is the same as our PM. Okay, so this is the same as saying 60 sine 22 degrees out of OP, which is 85. So that means our theta is actually arc sine of 60 sine 22 degrees out of 85. Okay, we press that from the calculator first. We have first of all sine 22. Okay, then 60 times that will give that, then divided by 85, then arc sine of the whole of that be 15.3 degrees. So theta equals to 15.3 degrees. Let's say to 1 dp. That's what we have. Now they want us to find the total distance the man moves. Also, the man has moved from this point up to back that point. So we say something like total distance covered is going to be OQ plus PQ, no, plus QP plus PO. That in that order. We have OQ given us. OQ was 60. That note there. Then we have this 85. 60 plus QP plus 85. So how do we get our QP? Let's say D. So here we have, but QP, we have 90 there, we have 85 here, we have 60 here, we have hypotenuse adjust, and let me say it's a right angle triangle. That means that side square plus this side squared is equal to 85 squared. So we have actually QP squared plus this OQ, which is 60 squared, equals to 85 squared, which is that. So we have QP equals to 85 squared minus 60 squared. So under root, then that is that. That means our D is actually going to be, now we have 60 plus 85, 60 plus 85 plus root of 3625. That, so our distance is actually given by 2052.2 meters to 1 decimal place. Thank you. Please watch out for my next video. Bye.